for the ISA Richland section. Today, we are here to discuss the new developments in the ANSI ISA 18.1-2024 Annunciator sequences and specifications. And we have two speakers today. We have David Brown and Mary Beth. Okay, the floor is yours, speakers. Proceed. Thank you.
Okay. I guess, Kevin, did you prepare any slides? I've got some, but I don't know if you also had some you wanted to share first.
No, I hadn't had time to do slides, so.
Okay.
On the Richland page, there are some documents on the above the invite, and
I put together some slides. It's no problem. Yeah. I'll go ahead and share. And I'll start from the beginning. So I'm pleasantly surprised to see here, Kevin. So I'll say this will be co-discussed by the two of us. So for everyone's awareness, I'm Mary Beth. I'm the secretary of the ISA 18 Standards Committee, but Kevin, he's the co-chair. So you've got two of us here to speak to what's going on in our group. So before we get started, something that's relevant to this discussion is ISA's new intellectual property policy. We were just made aware of this change last Friday, but it's going to affect what we talk about today to the extent of the details that we go into about the standards. It's all affected by this policy. It's going to very much limit what we can talk about. And so we're going to have to proceed with caution here. This isn't the complete policy shown. I've just highlighted a couple of the sections that are relevant to this discussion today. So if it feels like I'm being short and not going into enough detail, that's on purpose because of this. And that's all I can really say about it at this time. I encourage everybody to look at this policy yourselves and figure out what it means to you as contributors to the society and how intellectual property will be treated. Okay. So that said, everything I've put together in these slides comes from ISA's website. It's publicly available content. I can't really talk about anything specific in the standards beyond what's already publicly available. So that's my disclaimer for everything written and shared today. I'll give some background about ISA 18, our committee, and its purpose. So we talk about alarm systems for the process industries. Our committee name officially is Instrument Signals and Alarms. And, you know, the standards and technical reports that we maintain, they're aimed to help organizations maintain the quality of their alarm systems throughout a life cycle approach to make sure we've got one, safer process operations, and two, outside of that, more efficient. So I'm going to play this this video that ISA has published to market the ISA 18 standards, and that'll say it in their terminology. Can you all hear it, or do I need to share with volume?
Yeah, I think you better share the sound.
Yeah, let me go ahead and do that. Include sound. Okay. Okay.
In today's fast-paced process industries, every second counts, and missed alarms can lead to safety incidents, production losses, and regulatory fines. Introducing ISA 18.2, a game-changer in alarm management. This standard isn't just a guideline, it's your blueprint for transforming chaos into clarity. Imagine an environment where every alarm is meaningful, guiding your team to swift, decisive actions. With ISA 18.2, this is a reality. At the heart of this standard lies a comprehensive lifecycle approach, ensuring your alarm systems are efficient and evolve with your operational needs. Developing a tailored alarm philosophy sets the foundation for consistency and excellence, aligning every alarm with your organization's unique objectives. Prioritization and rationalization are key. By focusing on what's truly critical, your team can act faster, reducing downtime and enhancing safety. A well-designed human-machine interface ensures alarms are presented clearly, empowering operators to swiftly make informed decisions. Regular performance monitoring transforms data into actionable insights, driving continuous improvement and operational excellence. And investing in training and robust documentation ensures your team is always prepared, confident, and aligned with best practices. Don't let alarm overload hold your operations back. Embrace ISA 18.2 and unlock a new era of safety, efficiency, and profitability. Learn more at isa.org/ISA 18.2.
Okay, so here's the suite of documents that this committee maintains. So we've got two standards actually, 18.1 and 18.2. So that one was really geared at 18.2, which is the main one, but we do still have 18.1. So 18.1 came first, and I'll give a little bit of history in the next slide, but 18.1 is about annunciator sequences and specifications. So this was the first technology to the market before you had Windows-based alarm systems, computer-based alarm systems, when you still had panels. And there's still a market for that. And so we're keeping that standard up to date and modernized, and just considering what are the minimal essential requirements for maintaining those systems. But then the one that's got a lot more activity going on is 18.2. That's the management of alarm systems for the process industries, more of what you would think about computer-based alarm systems, but annunciator panels are still included in that scope as well. All of our technical reports over to the right fall under the 18.2 standard. So they don't roll up to 18.1, they roll up to 18.2. And these technical reports provide a lot more guidance than the standards do. Standards just say the minimal essential requirements in order to conform to that standard. Technical reports give a lot more helpful information and recommendations about how to do so. And I'll talk about each one of those in a bit more detail in a bit. So the history about the committee, chartered all the way back in 1955, before my time certainly, as Instrument Alarms and Interlocks, put together first a recommended practice about annunciators. Then that became a standard in 1979. In 2003, between 1979 and 2003, computers started taking off, and we started to move away from panels into Windows-based systems. And when that happened, you got a lot more alarms because they're super easy to configure now. And so that led to the need for a better alarm management standard. So that's about when it was chartered. In 2009, the first alarm management standard was issued. It was updated in 2016, and it's going through another update this year. Last year, we updated 18.1 and modernized it, and made sure we paid attention to the requirements, what's minimal essential versus a recommendation. Today, the committee, we have about 250 members. About 50 of them are very active and come to a lot of the meetings. About 11 countries represented. We have our chairs, Donald Dunn and Kevin Brown. Our managing director that liaises with the Standards and Practices Board is Greg Lehman, and then I serve as the secretary. A little bit about how we work as a committee. So we are consensus-based. All ISA standards are consensus-based documents. So we make sure before we're going to require something that substantial agreement has been achieved from the voting members of our committee. And we need to make sure we have more than just a majority, but we don't necessarily need unanimity. A unanimous vote, as long as we have certainly more than a simple majority. And then we consider all views and objections, and anything that we resolve is documented in what we call our comment resolution process for these documents. That's a little bit about how we work. Ethically, things that we have to consider for our membership. Our committee members serve as individuals rather than representatives of their employers. And also, committee members don't represent ISA or ISA 18. So when posting on social media, for example, we're not representatives of ISA 18 either. We need to be wary of avoiding real or even perceived conflicts of interest. We behave with the utmost professionalism and with respect, and we avoid inappropriate topics of discussion, including business competition issues. So that's a little bit about how we work and some of the things we have to be wary of as we're writing these documents. Now a little bit about each document specifically. So 18.1, like I talked about earlier, that was the first standard to hit the market for this committee back in 1979. So this was about Annunciator sequences and specifications and how to program them. It establishes uniform terminology, sequence designations, presentation methods to the operator. So if you follow this, you're more likely to do things the same way that everybody else does. And minimize error and have a safer, panel, Annunciator panel. Some of the benefits, standardized terminology, standardized sequences. It's going to lead to improved safety, reliability, documentation, compliance, flexibility, support for existing systems, and then any feedback. So that's common across any standard that you're going to come across. So 18.1 talks more about that. And, I hate to just read off slides, but like I said at the beginning with the new IP policy, this is all information that's available on ISA's website. So I had to copy and paste it here, and I've got to stick to this instead of getting more into the weeds. Okay. 18.2 is really where all the activity is going on today. So this talks about managing alarm systems in the process industries, the workflows involved, the technologies involved, specific to the process industries. It could be continuous, it could be batch, it could be discrete. They're all in the scope. And, as was shown in that advertisement video, there's a life cycle approach that's proposed. And in that life cycle, it talks about the minimal essential tasks and technologies in order to have a good performing, reliable alarm system. So some of the benefits are the same. You're going to have better safety if you follow the practices outlined in 18.2. You're going to be more organized following the life cycle approach. You'll have your alarm philosophy that's discussed in 18.2. It's your central idea document of how you're going to operate and maintain your alarm system. It'll help drive more clear alarm designs, more consistent alarm designs. Same with your human-machine interfaces, more consistency there and more optimization there. And then there's also the continuous improvement and monitoring lifecycle stage to ensure that it's not just a one and done effort, it's continuously maintained. And then there's going to be a team-based approach. And so you talk about roles and responsibilities that would be appropriate to have a part in this. Then you get into each one of our technical reports. So the alarm philosophy gives more detail about if you're going down the path of writing one for your company or your specific unit, you'd want to consider looking at this technical report for some really good ideas about what to include. Things like setting your alarm priorities, how that's going to be calculated based on, what the consequences are at your site and your process. And the time to respond. It gives guidance there, gives guidance about roles and responsibilities, like I talked about earlier, how to document everything and maintain that, and what advanced techniques you're going to be using. That's just a little sample of what's included in the philosophy. It also talks about how you're going to identify and rationalize alarms. So having that laid out in front of you to make sure it's clear. And then how you're going to manage the change anytime you go to change an alarm or even a whole alarm system. What are the expectations around authorization and documentation? Monitoring and reporting. How are you going to ensure that your alarm system is performing well? And how frequently you're going to look at it. And then, like I talked about, any advanced alarm techniques that you use should be documented. Our technical report too gets more into the alarm identification and rationalization lifecycle stage. And so this is a big effort. And if anyone here has already gone through alarm rationalization at your company, it's a large effort. And so it lists some good ideas. Sorry if you can hear the background here. I'm at my plant today. But it gives some good ideas about how to facilitate alarm rationalization and how to document all of that. So what's included in that, it talks about a master alarm database that houses all your rationalized and authorized alarm parameters and attributes, and then the prioritization methods. So when you're in alarm rationalization, that's what you're doing. You're assigning priorities to alarms based on the potential consequence of no action, and how long it will take the operator to perform the actions. And then how are you going to implement those changes and train operators on them? Then you start getting into alarm design. TR3 talks about the basics of alarm design, setting things like alarm set points and guidance for some good set point estimations and calculations, setting deadbands and on delays or off delays. These are some basic methods when you go to actually design your alarms. So TR3 talks about, if you do the basics, it's going to get you the majority of the way there in terms of having a good alarm system. And here's more of what's included. Like I said, this is all on the website. But then once you get into TR4, you start talking about enhanced and advanced alarm methods. So if your basic alarm methods haven't gotten you all the way there, and you're still having some flooding issues with your alarm system or nuisance alarms that are bothering the operators, that's when you might want to start looking at TR4's recommendations on maybe you need some enhanced and advanced alarm methods. So advanced alarm methods, things like mode-based alarming. If your plant is in shutdown mode, can you automatically, disable a subsection of alarms because they're not relevant? Things like that are advanced. Enhanced would be, can you give your operator more dynamic information about the cause of an alarm? Instead of listing all the possible causes and they have to determine which one it is, can you more readily available give them more information about what's actually the cause at that time? So that talks about more of those enhanced and advanced alarm methods in TR4. TR5, the life cycle stage of monitoring, assessment, and auditing. You capture all of them, all of those life cycle stages in this one TR right now. It talks about what metrics would be good to implement to make sure your alarm system is performing reliably, and what are the best to look at to start with in order to make the biggest impact and the biggest changes. And then auditing, who needs to be involved and what are you auditing against? Well, your alarm philosophy and guidance like that. So here's more of what's included. TR6 discusses pretty much every single life cycle stage, but with the scope of batch and discrete processes. So it was recognized that a lot of the content is geared toward continuous processes, but batch and discrete processes do fall under the scope of 18.2. But maybe if you're interested in them specifically, you could just start at this TR and it goes through every single life cycle stage and considers, well, for batch and discrete, here's how you want to consider it. So for example, alarm system models specific to batch might be relative time versus absolute time, relative to batch step, things like that. This TR goes into detail about considerations on every single life cycle stage for batch and discrete. And then the same with package systems. It's pretty much the same as the batch and discrete TR. It considers every single life cycle stage, but from the lens of package systems and what considerations to keep in mind for those. Communication interfaces, if you're going to link it to a common supervisory system, best practices to do that for alarms and things like that. And then finally, our last published TR, guidelines for non-alarm notifications. So you all probably know there are a lot of alarms configured that maybe aren't necessarily for the operator, but that's the person that they come to because it's through the automation system, the control system. So this technical report gives guidance on, can you better direct it toward a non-operator role if the actual action to be performed is not for the operator. So it gives different definitions for types of notifications that aren't necessarily for the operator, or they aren't necessarily considered alarms. Maybe they're urgent notifications requiring a timely response, but they're not abnormal, for example. So it goes more into those definitions and guidance for each type of notification. I've included some links to purchase, and I'll send out this slide deck afterward, but in a nutshell, this is what you're looking at. You can purchase them individually, each document. If you're a member of ISA, you get a discount. If you're a committee member of ISA 18, you can view them for free because we work on them as a group and try to keep them up to date. You can also purchase all of the documents as a bundle and save. And the bundle pricing also has a member and a non-member price. I put an asterisk here in the member pricing column because if you're a member, you can actually, if you're an ISA member, you can view all of these documents for free, but you can't download them to your computer unless you purchase them. So that's the catch. The active efforts our committee has going on right now, we're working on 3 documents. First, we're updating the 18.2 standard. So IEC 62682 has been published. And so we are looking at aligning to that now. And also we're looking at some considerations from ISA 84 regarding process safety alarms and independent protective layers as alarms and what content we're going to include in there. So we're going through an update of this standard this year. And then we're also looking at updating our TR4 on enhanced and advanced alarm methods. So that was published back in 2012. It's been over 10 years, so we need to modernize it. So that's an active effort going on. Then you'll see at the very bottom, I haven't gone over this new technical report, TR9. This is new, it's not published. It's on the digitalization of alarm management. And so we're still going through content development on this one, but that is an active effort at this time. And here, if you're interested in joining the committee, I've just put in some information about how to do so. Standards committees are open to anybody. You don't need to be an ISA member to join. You just have to fill out this form online. It's going to ask you which committee you want to join. You can join just ISA 18 or any committee that you have interest in. And then it's going to ask something about your interest category. So I want to talk about that real quick. You can either be a producer of that applicable topic, a user, a general member, an architect engineer, generally called EPC. You could be in the testing or certification industry, or you could be regulatory. We need to have a mixture of these interest categories and a balance of them in order to have a good voting membership participation and balance. So this is something that we track. So if you have any issues filling that out, what's applicable to you, just feel free to reach out to me and I can help you fill it out based on where you work. And when you start out as a member, you automatically start out as what's called an information member. You don't have voting power at first, but the more you participate, the more we track your participation points. And in time, you can become a voting member through a ballot. So the voting membership pool can vote on whether to make you a member or not, as long as we're still balanced among our interest categories to make sure we're getting enough industry participation. And that's all I've prepared. So at this point, that's all I can really speak to without going too much into the actual standards because of the new IP policy. So, talking with Brad about how we wanted to conduct this session, we talked about a Q&A format would be better. So I'm going to open it up to questions, or let me start with Kevin. Kevin, was there any other, as the co-chair, any other information you felt pertinent to share or update with the group?
No, not at this time. I think you covered it very well.
Okay. Well, we'll open it up to everyone then. Any questions?
Well, I'll be the first question. I looked at Eddie Habibi and Bill Holofield book, the alarm management book, the thick document. Can you hear me okay?
Yeah.
I unmuted myself. And how does their book follow 18 standards? And do you find it a good reference? And is there a better book if they don't want to spend the $1,400 to buy all the standards? You can buy Bill Holofield and Eddie's book considerably cheaper. Are there any other people? Have any other people wrote another book about alarm management?
Kevin, you want to take this one? I haven't read the book, so I can't speak to it.
So overall, Bill Holifield's book covers all the topics. it's obviously based on the direction that Bill and Eddie would like or liked or would have had alarm management go. And within ISA, it's led by all the leaders in industry. And because we do consensus, there may be something that I feel strongly about and I would like to have in the standard. But because I can't get enough people to agree with what I would like to propose, then it doesn't necessarily get it put into the standard or a TR. Whereas when you look at Bill and Eddie's book, it's really based on their opinions and the direction they want to go with alarm management. Does it deviate a lot from the ISA? There is sections that do. Is it a good book to read and get started in? I would not say it isn't. It is good. There is no other books that have been written. There's several papers out there. Myself, Donald, Nick Sands, several of the ISA members have written papers that are available. Most of those are free and available through the different organizations that we've written them for. So that gives you good documentation too. So not another book, and it really comes down to where you want to go with your alarm management.
I guess I'll ask another question.
Go ahead.
If
Brad.
nobody else.
Go ahead, Brad.
Something that I had been telling Udo that he ought to set up. He said they were working on alarm management, and I suggested that they set up steering committees at each of the company's facilities throughout the country. Have just one or two people from each facility, and just implement the alarm management their new alarm management, and get control systems involved, get production involved, operators, and to figure out what their alarms are, and then get steering committees. Is that a valid way to do it? Is that suggested? Do you find other companies do have steering committees, and they'll meet periodic, maybe face to face once a year, and rotate to the facilities? Is that a good way to implement alarm management?
Yep, that's a good way. Depends on your company and what would be supported. It could be supported on probably what would be a volunteer basis at first, soliciting volunteers from the different sites of that company to participate and give their feedback about, here are some pain points we've experienced. Can we put together a best practice on this topic internally to share? Or can we put together a template alarm philosophy? Or can we standardize on some alarm monitoring software? Questions like that could come up in such a steering committee. Yeah, that would be a good approach.
Yeah, so how we approaching that right now is we're trying to distinguish between alarms and events. So what should be an alarm and what should be an event, So I think an event is just, just for the operator to know what's going on. Maybe something happened. But an alarm is something that would have the operator jump off his seat to actually intervene to see what's going on. So that's how we're defining that right now.
And the definition of an alarm is given in the 18 series of standards, 18.2. So definitely look at that standard for the definition. I can't share it with you, but for the IP policy, but it's there. So that can help.
Okay. Thanks.
My question will piggyback off that exchange. Basically, I'm going to have two parts or two different questions, but I'll go with his first. And I was reading in this, I think it's part 8, talks about notifications and events and things of that sort. And I've had projects and we had an issue at one of the facilities where we had distributed water treatment, water handling systems, management systems, and wasn't staffed. Certain parts of the facility were not staffed 24/7. And so, and that included the control room area. And who takes over and how do you get notified? I'm familiar with the old ways. It used to be dial up, and now they say, well, you can link it to a cell phone. And other ways to notify the identified person, or the shift manager office or whatever, is what we did. And we had a fiber optic link to not a laptop or a iPad. It was physically mounted on the wall for his use. But trying to identify what the notifications that are essential in the events, and how to, there's nothing in the standard or the TR that says how we distinguish the tagging for all these. It's very obvious if you've had any experience in controlled instrumentation based on S5.1 on how to tag process tagging for instruments and that sort of stuff, measurements and sensors and that sort, that lead to eventually the alarm setting. And that's also oftentimes on a PNID. Like a pressure would be a pressure alarm HI, which is very critical to engineer that up front. But there's not a lot, there's nothing on S5.1, I don't think, that has, or there's very little that says this is a notification that needs to be addressed and then sent to, in addition to all the other things, that needs to be sent to the key decision maker for the process, the operating manager. And that's my comment. There's some shortcomings in that part 8 that I have a comment on, at least a subpart question. You have how to join the S18. How do we send? I understand that a lot of actions not performed unless you send comments in, and then you, as a standards committee, have to respond and review and evaluate and incorporate as necessary those changes or comments, especially if they show they lead to shortfalls in the current standard. What document or how is the best way, and let me write this down as you speak, to approach this 18 committee with comments, and then on how that's followed up by as a response. And I can see my question and I can see the response, and I want to make sure that is made available to all the other committee members. Do you have a spreadsheet that you use to land that comment into a spreadsheet, and then you resolve it, and then you have your response as another as part of the process?
We have commenting periods, time periods where commenting is open, depending on what document we're working on at a given time. So let me go back to that slide. Here shows the 3 documents we're working on at the same time, kind of, but each of them will have a different commenting window. So for example, in March of this year, 18.2 was opened up for a 30-day comment period. So that comment spreadsheet was sent out to the ISA 18 listserv, and anybody could comment on it. So you could go through it in that way. And then you have these other documents. When it gets to a commenting window, the commenting spreadsheet will be sent out accordingly. And, there are standards and procedures that say we have to have that window open for at least a given amount of time to give people plenty of time to comment. It's usually a month. But depending on when we send it out, for example, if it's during the summer months, a lot of people take vacations, or if it's over the holidays, we might extend it. So that's when comments are accepted. Depends on what document we're working on at the time, but they are accepted from anybody. And we do have an obligation to go through each and every single comment and resolve it. And once we do that, the comment window, when it closes, Whoever is leading the effort on that document will schedule comment resolution meetings to ensure the technical comments are addressed with consensus. There are different types of comments. It could be an editorial comment, which are things like you forgot a comma, you misspelled this word, or it can be technical in nature. And if it's technical in nature, it requires the consensus. So it has to be resolved during a comment resolution meeting. And so if you submit comments, you're expected to participate in the resolution meetings and make sure that your comments are addressed. And that's the format that we follow. Kevin, did you want to add anything that I missed?
Just other than once we've addressed that comment, it's also captured in the same spreadsheet to the decision and what was decided on. So you could make a suggestion and a change, and the decision might be that we're going to accept that request, but with modifications, and we'll list out what those modifications are and the reasons behind it. So we try to be very open to that. We're trying to be very black and white so that you can see how these comments are addressed and why.
Well, but
And it's
what I'm getting
something-
from this discussion basically is that it's more streamlined, especially with all 250 different members, to become at least a initial member, whatever the title is for that, and submit your comment, and then you'll be allowed to track that as it goes through the whole process before the approval of the revision to the standard or the TR.
Exactly.
So
So I understand. Okay, that's
that's-
my first question. I have a second one if you can give me time, and this is something, again, I don't see really addressed. And that's in my work as many DCS systems. We have basically non-engineer types that are programming these DCS graphics and populating them to the extent that that company, whatever that company is, has a standard approach in training of their people. But there's not much. And when I addressed the issue of alarms per 18, IS 18, oh, we follow that. Well, then I'll lead to my evidence. The computer-based alarming systems have opened the door to just flood with settings. And people are just putting in there the 100% or 90%, 95, 80% pre-alarms. They basically, in my experience, they don't have a concept, and it's really not addressed in the documents that I was able to get through to review. Pre-alarm condition. Why are you worried about that? Well, you don't want to worry about when you're at the catastrophic full alarm scenario, when you're overflowing. Like I had a seawater cooling pump station, and you overflow because of a level switch that malfunction. It overflow, instead of overflowing a small little tank or a 50,000 gallon tank, it's going to be millions of water. And when it reaches the crest of the boundary wall, it floods over all over the place and down into the pumping and equipment area. So it's critical. And you can't expect an operator to operate when it's hit the high level point. I mean, you can, and we don't care about having alarms when it crest. A tsunami, I don't care about if it's 6 inches flooding over. It's too late. I need a pre-alarm condition. And that's not really seems to be the thinking is not really laid out. And what I'm suggesting, if you get people to look at your standards, they need to have those fundamentals when they're designing these alarm points.
And that's exactly
and
the reason.
Some of these features are not in your standard. And
they might not
go
be in the
ahead.
standard, but they're going to be in the technical reports. So the standard is going to be the minimal essential requirements, but the technical
Which
reports.
Which one has that then? Which one should
Sounds
I
like
be
it's going to
looking at?
be TR3, basic alarm design, will help
Okay,
you
I didn't get
figure
to that
out
one.
how to set
Okay, I didn't
points.
get to that one.
Mhm.
Okay, I'll look at that. I appreciate it.
So
Yep.
There's
Okay,
something
that's
just
part,
wanna.
that's part of it. But if I can continue on one other, they
Well,
also
just
seem
give
to
me a
populate,
section
they want,
to, or just give me a chance to respond, is
okay,
that,
go ahead. Yeah, you can.
when you're looking at alarm design and, talking about pre-alarms, you're using, technology or terminology that is, what I would call 1980 dated. And what I mean by that is that's the way people thought of alarms back in that 1980 era that led up to a lot of the alarm issues that we had. And then we started to develop standards and move forward with improved alarms. So when you start talking about pre-trips and trip alarms, that's not really a function of the alarm documents. So if you go into our documents and you start to look for pre-trip or trip alarms, you're not going to see it listed that way. And so I just wanted to, as you read the documents, you need to take the content in and understand what it's explaining to you based on the text and not based on looking for some terms, because you won't find it in there. We no longer promote pre-trip alarms. Every alarm that activates requires an operator action. And if you're talking about the simple example you gave on an overflow, that alarm that occurs should occur with enough time for the operator to solve that problem. And that's laid out in how you do that in the alarm rationalization and time to respond. So I just wanted to give some clarity, and that could be some of the misconceptions with some of the people. It's also been something I've seen promoted by DCS vendors, and especially SIS, when they start talking about SIS safety systems, and they start talking about alarming. So I hope
So-
that helps, but
Well, that's the practitioners that you're describing, the DCS people and the SIS people. And if they haven't evolved to, and I didn't hear a distinction really from what you said and from way in practice it's done. Of course, that's understood. A pre-alarm condition is anticipating, and you're calculating the time for an operator to respond and that sort of thing. And if you're talking on millions of gallons of water in 15 seconds, that's a lot of water, as an example.
I think what he was getting at was you're not going to find that term pre-alarm because part of what standards do is standardize terms. So what terms are acceptable, what are not. And he was saying the term pre-alarm, we've kind of moved away from that because it would just be considered an alarm in and of itself if it's necessary. You know, if you go through rationalization and deem it necessary to be an alarm, it's an alarm.
Okay, well, I'm not going to argue that point. I really concur with what you said, and I want to make sure there's no distinction between what I said and what you said in practice. Okay, and we carry that out. If we don't use the term pre-trip, that's fine. The other thing that I run into when I've done a lot of DCS projects, again, these designer level folks don't understand the concept, and they try to populate 25%, 50%, 75%, 100% without much thought given to it. I agree with you. They need to do some calculation. They need to have, but these vendors don't seem, at least in my experience, to in practice implement that. And I don't know what documentation you provide as part of a project up front based on your standard, where you give them and you feed them that information, and so that they do duly provide that and program that in. But secondly, not to carry it so far as to overdo it and create artificial alarms. This goes back. I have other comments that then lead into this notification and these other terms that you use in part 8. So go ahead, please.
Yeah, so we do talk about that in some of these documents. So depending on what kind of specification you're talking about from the vendor, you could look at the alarm philosophy technical report, TR1, and that talks about, you know, your system requirements and how you're going to specify those and exactly what you're talking about. At what point do you do that and what things do you need to consider? But then if you're talking about vendors for maybe package systems, maybe you look at TR7. So if you're going to get a package system that comes with alarms pre-programmed, and you need to have that conversation with vendors, maybe look to TR7 for guidance about how to do that.
Well, one thing I
Okay,
just
well,
want to
that's,
mention, and maybe just to pull everybody back, is these are documents that people have to apply, and if applied correctly, they will function and work for you properly. However, my experience is, and I do a lot of work with and have worked with a lot of companies around the globe, is that and I don't know how to say this without sounding negative, but the truth of the matter is there's people and companies out there that have very little or limited alarm knowledge, including DCS vendors, who then promote that they can configure what they want for their alarms, and they're not applying any standard, whether it's the API 1167, which is pipeline, or IS 18, which is process industries, or EMUA in UK. They're not applying any of the standards. They're applying what they believe alarms should be, and then saying we comply to the standards. And that's the misrepresentation that's been presented out there. And I think the way to verify that is when you ask them, do you comply? Then ask them, who do they participate with? Are they participating with 18.2? If that's the industry they're in, how long have they been participating? And then verify that they have been. Alarms, and I speak from experience, and I hate to admit it, but I did 20 years of process controls prior to getting into alarm management. And for me, alarms were just something I had to do. They were a nuisance. You know, yeah, okay, I'll configure them, I'll put them on. Never gave it a second thought. My job was to develop process control strategies to make the facility run better, more efficient, product wise. And so that's what I did. So there's a lot of people out there that deal in, especially SIS, some of the more complex systems. When they look at alarms, it's, oh yeah, we can do that. It's just an alarm. How could you mess that up? And that's where the mistake lies. So I would just challenge the vendors that you're talking to, you know, instead of saying, do you comply, and have them say yes, is, are you actively involved with these organizations, and do you participate on a regular basis?
well, I concur with that, and that's been my practical experience, is that they say, oh yeah, they meet all these standards and they have the capability in the software, but they don't have the fundamental engineering or process background, or they know that the process or the batch discrete process they're working with, or whatever, to implement what is, you know, is readily considered to be, it's handed off to them, and basically it doesn't get done.
Oh, you haven't done it
Correct.
yet?
Over there.
You're not done yet?
No.
I'll ask.
So that's that part. But I want to go back to my question on the notification business. I really struggled over that, and that's not something that's is addressed very readily on the PNIDs. That you have the critical things. When you're coming from an instrument on a process, it's fairly easy to identify what you're going to have alarms off that pressure, and how many alarms that you want, and or levels for or flows. But when you want to notify somebody, of something. Some of that stuff is not really readily able to be portrayed on a PNID. And you can have it in your, like you said, your alarm philosophy document that you generate for the project, and you can put that in there. I can see that. But that all leads to my final question. I've had a lot of experience with alarm historians and that sort of thing. And I mean, you combine and consolidate a huge plant with your process and then your package systems and maybe even some discrete stuff. You bring all this multitude of points in to your alarm historian and how you track that. And then you got to ship that to another remote congealing or combining system where it has its satellite, it has its own varied subsystems, and it's got to consolidate all that into one historian. And the tagging is critical to have consistent tagging across all facilities. And I just wondered in your experience, for your working experience, as an example, how did you handle the tagging for notifications? Because it's not really readily addressed in these, and you don't have examples of how to go about what is good practice. So I was wondering if you could help me on that.
It's kind of the scope of a different standard, I'd say, how you're going to tag it. But Kevin, do you want to take this one?
Yeah, there's a lot that goes into tagging, and ISA, and I forget the standard actually deals with, it's something I could look up, but it deals with how you want to tag your system. At the different sites I've been, some of that tagging limitation can be done or is based on limitations of your DCS system. Such things as you can't have the first letter or alphanumeric. It has to be alphanumeric and not a number. So there's some limitations within the DCS system to do that. So tagging is handled within ISA. It's outside of our standard. What we've done is recommend what type of alarms and then how you present them to the operator and into the alarm and event database is based on how you decided to tag it. It's not something that's as black and white or as easy. I've worked in lots of different industries. In fact, I'm working for a client right now. Their plant's only 4 years old, and I'll have to be honest. And I've told them, so I'm not saying anything that I wouldn't have said to them. Is their tagging convention they used? I don't know where they got it from, and it's the worst I've ever seen. So I'm not sure how that comes about, and I agree with you that tagging is a bad thing, but it's not really in our scope for alarm management. The tag is already decided on the PNID. It's a pressure, 12 PIC 1001. And when it comes into the DCS has the capability now for us to configure it into a high alarm, a low alarm, a rate change alarm. And that usually gets some type of underscore or dash associated with that type of alarm. So it's really not something that we delve into.
Well, I would suggest, or that'd be a comment of mine. I'm sure it's been addressed somehow, but
Sure.
when you package a bunch of ISA standards together, they're needed to do that effort. And 5.1 would be a very critical and very important one. I don't have lots of money to go out and buy all the standards, but you have a strong reliance on going to, I think it's HMI 105.
Well, let's remember,
and
if you're an ISA member, you can view a lot of the standards for free. You can't download them unless you purchase, but you can. If you're an ISA member, you can view a lot of these for free.
Well, I'm basically saying one thing I need to look at is the 105. I think it's 105, the HMI. And how does
101.
that expand, or how's that expand or tie into this? Can you, I know you can't tell us much, but I would think you'd be able to give the upper level picture of how that works into setting up your
very
alarms.
high level, there is some overlap in the two. And so the ISA 101 group is a group we often liaise with. But at a very high level, yeah, our documents talk about presentation methods to the operator. So recommended colors or noises to present alarms or notifications differently to the operator and things like that. We do touch on that. But we refer to ISA 101 as the standard that has
Okay.
jurisdictional authority over all things HMI.
Well,
Yeah, I have a question.
Yeah.
Go ahead.
Throughout this conversation about the standards for alarms, you guys have always talked about DCS, and there has been no mention about PLC. So is it just directed towards DCS systems?
No, it's inclusive of PLCs, SCADA systems,
Okay.
DCSs. Yeah, it's all automation systems within the process industries are within scope.
Okay, because there was no mention of PLC. I was just saying DCS. So
DCS just tends to be what we talk about
Yeah.
most often, but it's
Okay.
it's PLCs
It's-
as well. So that's where you go to this TR7 package systems are often, they come together as a packaged PLC. Maybe a vendor will program it and ship off this piece of machinery to you. And then batch and discrete processes. Maybe you have a lot of discrete processes operated by PLCs. Those are within the scope. Yeah.
okay.
Yeah.
Looks
Yeah.
like most of you are from the process industries. I'm more on the PLC side. Yeah.
Well, I mean,
My
process industries, you could
experience-
have continuous process industries, you could have batch process industries, discrete process industries. They're all still processes. So,
Okay.
yeah, whether it's continuous or not, yeah, we talk about it.
Yeah.
So we
And
do have
Udo-
people on the committee that are from different aspects of the industry. If you look at myself, I've worked in process industry. I've also worked in batch, and then probably the last 10 years in pipelines. So that's one of the things we look at in our membership is we do want to get that varied experience and knowledge to come forward and speak to the challenges they have and sort those, and then we can discuss those in our TR developments.
And Udo, I would say, think of the definition of what a DCS stands for, distributed control system. Now, hopefully your PLCs talk to a common multiple PLCs. Think of the PLC is a controller. And so you've distributed, and hopefully your PLCs all talk to each other, or not talk to each other, but all communicate to a common HMI. And so effectively a PLC can now, that line between DCS and PLC is so almost negligible. It's so blurry because, I mean, when PLC started, they were just bringing in digitals, motor starts, and that sort of thing because they couldn't do analog PID control. So I mean,
I think they're just two different things at this point, because there are some places you can't use the ECS. For our systems, we don't use DCS. Of course, the PLCs communicate with each other, but it's just more produce and consume tags just to let the next process know that the process has finished so it can take over, right? So that's how we use that to communicate between PLCs, but they don't run the same process. I know DCS systems like Delta V, right? And those other systems, they have multiple IOs scattered all over, and they have just more like a distributed PLC network. That's how I understand it.
or how about a distribute?
So I think we're getting hung up on terms
Yes.
and how we implement. When we start to look at functionality and when you look at a PLC and some of the newer PLCs that are available today, like Siemens, you can add an HMI on top of it, and it can look like and appear to the unknowing person that it's a DCS, when in fact it isn't. It's a PLC. It has IO cards. It looks like digital cards in it, and it displays HMI. SCADA system is most SCADA systems attach via some type of communication link, not direct link, to PLCs. So we're getting hung up on specific terms, and I know that sometimes we default to DCS, and I think it just became a common term that's been around for probably for the first 10 years of industry where the HMI existed on. But really, it's computer control systems now, automation. If you go look in our documents, as Mary Beth said, we don't say DCS anymore. That's probably a mistake on our part saying DCS, because we do consider all computer control systems.
Even SISs as well. So we talk about alarms from safety instrumented systems. So that's all within scope. Any industrial control system, ICS maybe is the standard term within the process industries fall within scope. But hey, folks, I have to run. I've reached my hard stop.
It is the top of the hour.
Yep.
Yeah, I've got to run as well. So.
All right.
Thank
Well, I'll
you.
send the slides over to you.
Thank you, Mary
Brad.
Beth.
Yep.
Thank you,
Absolutely.
Don.
Thank you.
Kevin.
Thank you, Mary
Good
Beth.
job. Thank you.
Thank you.
Thank you all for
Thanks.
attending.
Thank you all. Bye.
Thank you. Bye-bye.
Hello, Ed and Brad.
I do. I did my
Interesting.
lunch during this
Okay.
meeting.
Yeah, I've got
That's the way it goes.
You got to
I've got
run.
to go. I've got to go back to training. I missed my free lunch. So I'm going to close the meeting here.
Okay.
But
So-
thank you, Brad. This worked out to be pretty good.
Yeah, take care.
See you, Barb.
too.
Bye.
Bye.
See y'all. Bye-bye.